All right, let's get started. This is the March 2022 OpenZFS leadership meeting. I wanted to start off just by saying that I've been following the news in Ukraine, and I know that there's a number of developers in our community from Ukraine and from Russia, and just wanted to say on a personal level that it's a real shame what's happening there, and I hope that all of you and your families are safe. If I don't know, it's a real shame, and I hope that you're all safe. All right, on to OpenZFS business. I saw there were a couple of things added to the agenda. Rich, I don't see Rich here. Rich has an update on compression that he put in the agenda. Looks like he's working on modular compression versions, which is cool. So look forward to seeing how that turns out.
Yeah, I don't know if he finished it or not, but
I'd like to share.
He and I were working on LZ4 on by default as well, which was a minor change, although it seemed to tickle a bunch of things in the test suite that he had to poke at. I don't know the status of that off the top of my head either, but I know that was another area he was poking at.
Yeah, I was looking at that myself. That actually came along pretty nicely. That ended up being like a lot of little bits in the test suite to fix up, but I think that's in good shape now. There's a pull request open, and it's needs final reviews probably, but should be good to go in.
Great. The only other agenda item I saw was review requests. So Alan, were these yours?
Yes. The first one was a small one that a customer did, I think back in the summer. Basically the startup service script to be able to load and unload encryption keys automatically at boot for their database and so on. And I think that was just a matter of that ending up in the contrib directory or something like startup scripts normally do. I think that was just a small one that maybe fell off people's radar. And then I have the bigger three features that we've been actively chasing for review for a bit now.
Let me see. We're a little light on attendees today.
Mm-hmm.
Let me see if I can check who needs to take a look at these. Bring them up. All right, so the ZFS keys script, looks like Ryan took a look at this. And I can ping Tony on doing another review or finding another reviewer. The rate throttle smoothing. So I should probably take a look at this since I wrote a bunch of this rate throttle stuff earlier, way earlier. I haven't really had a chance to look at it at all, but I will put this on my short list. I love your little graphic there, the graph.
I think Alexander's point in that one, I think he was surprised that space goes back into the basically available dirty, or that the amount of dirty goes down very sharply all at once rather than kind of as things are flushed out. So it's like once the transaction group completes, the dirty data drops down sharply all at once. And that seemed to be, I think, maybe the root cause of why we would see the VM being able to write to the disk or write to ZFS faster than the disk could possibly go up until we hit basically the brakes because we were running into the dirty data max. And then we'd see a stall for a couple seconds where basically the VM could do no writes, and then it would jump back to being fast and then stall and fast and stall. And so we basically said, once we've had to apply the right throttle, keep the throttle on for a couple of seconds so that we get smoother instead of this kind of spikiness. But Alexander, I think you had some thoughts on that.
No, yeah, that's exactly what I told. And I remember, Matt, you was working on that before, so that every completed write should decrement amount of dirty data.
Yeah,
and so it should be pretty smooth. That's either something got broken or some kind of traffic is not accounted there. Maybe dedupe, or I don't know what else, what other kinds could there be, or some mass errors that get accumulated. But like it should be more or less smooth. It should not be required.
This was writes to zvols and with no dedupe.
Yeah, there might be some special cases, like you said, Alexander, but yeah, like the common case, it should be decrementing that as we go, as the rate's complete. I think there's some.
But like, when does the write complete? It's when the transaction group syncs, right?
No, yeah, I mean, when the transaction group syncs, when it's in the middle of syncing, like as each IO completes, it should be getting decremented.
At the end of commit, it should just decrement whatever left in transaction group.
Yeah.
In ideal case, it should drop to 0 and there should nothing left. But if something is left, it's probably something not properly accounted.
Yeah, that's exactly right. I think there are some known corner cases that are eluding me right now. But I don't think it would be related to zvols. So if you're seeing that like all the time, then we probably want to look into that, because that will be a bigger improvement. Once that's working, then you should only have that like remainder, like Alexander said, that is dropping quickly. And then there's definitely fluctuations, but they're much more minor normally. Like at the very end of the TXG, you're not syncing as quickly because you're waiting for the last few things to happen. So there's no activity then. And then, until you start the next TXG, there's no activity. So you expect fluctuations there. But I wouldn't expect to see the whole thing going to 0 at the end of the TXG.
It's not quite the whole thing, but it didn't seem as smooth. I think I have another graph here somewhere. Okay, it's a little blurry, but this is what we saw the dirty data
and is
buffer
that
looking
0
like.
Down at the bottom there?
Yeah.
Okay.
I don't know why it came out so fuzzy.
Yeah.
But it doesn't seem to drop vertically. It's not like
not quite vertically, no. But
yeah, so I would guess that this is probably normal, where you see it like it's dropping, and it may be that because it's gotten so high, it would be interesting to know, like at that peak, how much delay was applied.
Well, when I think when it's hitting the top there, it's having to completely stop because there's no dirty data buffer left at all.
Okay.
But other than that, the max delay is 100 milliseconds.
Yeah. Right? So one problem might be that like once you hit the max delay, then it can take a little bit for the workload to be allowed to like ramp back up, because the max delay is so big, 100 milliseconds or whatever. So it may be that like the reason it drops down so low is because like the workload isn't like adding more dirty data as quickly as really we should be letting it. As there's more available dirty data, you know what I mean?
Right.
Like when it's going down there, really it should be like leveling off and being flat at a non-zero level as like more dirty data is being added by the workload.
Yeah, like it should kind of be moving back and forth along that curve like we should have in
Yeah,
the
like in
pull
the
request.
yeah, and it should be like in the upper, I forget where, like it kicks in at, I mean, the throttle doesn't even kick in until you're at a third of the dirty data limit.
I think the default is 60%.
Oh, it doesn't even kick in until you're at 60%.
Or no, that's not right. When does it kick in?
The source code.
It starts to sync at 20% by default, but
but then the delay doesn't kick in until.
Is it 60%?
Delay min bytes. Where is this coming from? Dirty data max. Delay min 30% right now. Just let me click through. It's ZFS delay min 30%. Whatever that defaults to. Waiting for my search to complete. Some other file. Well, that'll come up eventually.
Yeah, it looks like
it's not
ZFS
zero.
delay min 30% is 60.
60, okay. So yeah, so it's not even until you get 60% dirty that there should be any delay. But depending on the time scale there, like it may be that all of the application's threads are like waiting for IOs to complete. Do you know in your graph there, what is the time scale, like the kind of period of that oscillation?
I think it's just that the whole graph is only a couple seconds. I have to ask Marius that made it. But.
Yeah, so if that's the case, then that could easily be like the max delay being 100 milliseconds. It could be like, okay, all your applications are in there. They've hit the max delay of 100 milliseconds, and now they can't do anything for another 100 milliseconds, even though stuff has been fleshed out. You know, when we wrote this originally, it was in the context of spinning disks. If you're running on SSDs, it could easily be the case that like that 100 millisecond delay is just like ridiculously long. And you know, I've seen this a lot on SSD pools where like the TXGs can sync very quickly because you know the max dirty data is 4 gigs. Like, it doesn't take that long to write out 4 gigs if you have a bunch of SSDs. So you know, you can kind of work around that probably by like decreasing the max delay as kind of a stopgap. You know, so instead of 100 milliseconds, make it like 10 milliseconds or 1 millisecond or something. And then, you know, you may also look at increasing the max amount of dirty data from 4 gigs to, you know, 16 gigs or something. So,
in this case, the target machine only has 8 gigs of RAM, so we didn't really make it bigger. Wow. We were making it smaller, but yeah, we were just seeing to the point where the application was just stalled completely, and by and we basically kind of, even with, we lowered the point where we start inserting delay from 60% to like 30 or something like that. Yeah. And I think basically what we saw was that, you know, the application would go full throttle and it would end up running into the dirty data max and having to slow down. And then the throttle would stay on for the writes after that as it started to flush stuff out. But as soon as it dipped below the insert the delay value, it would just flood the dirty data again. I think partly just because they were using so many threads as opposed to, you know, a single number, a small number of writers. And then it would just run into the limit again. And so our solution was, you know, once we've had to apply the brakes, you know, don't go completely unthrottled again until we've stayed below the threshold for a number of seconds.
Alan, it just got to my mind. Since you say you have so many threads, it may happen that if all of the threads came same time and each of them will increment weight more and more and more, the last will get queued in situation when first haven't even yet completed. So practically your delay is not increasing gradually, but it just goes all the way to the max. And then, as Matt told, you get some 100 millisecond delay when really everything is blocked.
Right.
So would you have one thread? I guess it would get throttled pretty gradually and maybe wouldn't get to that critical point.
Mm-hmm.
I'm not exactly how should it be fixed, but
like I wonder if can we like wake up those threads once we dip below the threshold again or something to make sure they're not waiting needlessly? Or I think they already do that though, right?
I think that Alexander, I think that the fix would probably be like, probably what we're doing is, you know, when you check how much delay you should have, it's based on like the amount of dirty data, right? But like you said, threads might have been allowed in, but they haven't yet actually dirtied their data. So we probably would need something where it's like, okay, like you're coming in, you're checking the amount of dirty data, you want to dirty some data, however much data you want to dirty, we add that to some like, you know, pending
reserve dirty data
reserve,
or something,
right? So it's like you don't get to go until you've incremented this like reserve dirty, and then, you know, and then when you go do the actual dirty, then you like clear out your reserve dirty as you're doing the increasing the actual dirty. That way, like the amount of, and then when you're checking the amount of dirty data, you're adding in this reserve, right? So that,
well, yeah, it would make it independent from number of threads. You're right. I don't
exactly.
remember when it's incremented, but if it's incremented first before check, then sure, it may be a problem.
Yeah, I think that would be like the right solution to having a lot of threads. There's other things in there that are supposed to handle like having a lot of threads. Like once you start delaying, then the delay, then it should kind of, the delay should work irrespective of the number of threads. Like if you have a lot of threads, then it's like, and the delay is 1 millisecond, then like the first thread waits, if all the threads come in at the same time, you wait a millisecond, then one thread gets to do something, then another millisecond, then another thread gets to do something. So you can't flood it like that, but the window there, like you're saying, between when you check and then when you go and dirty it, could allow a lot of threads in.
I now trying to recall the code, and I think each next wait is starting from the end of previous one.
Exactly.
So if you have 100 threads, you'll get scheduled 100 waits in advance. So your latency will grow even much higher than it would be with single thread. So the moment of dirty data increment may be right, but it may be only half of the problem. The other half is that they are all the right weights are sequential. Like if each thread waits for 1 millisecond, then 100 threads will wait for 100 milliseconds. No, last of them will wait for 100 milliseconds.
And then I wonder if like, if you hit that max of 100 milliseconds, then it's like 100 threads times 100 milliseconds. Like the last one is waiting 10 seconds or whatever that is before it gets to issue, which is like ridiculously long. You know, I think that when we designed it, and when I observed, you know, a long time ago, was like you almost never hit that maximum, because it ramps up, you know, as you get towards the end, it's ramping up exponentially. But so you know,
I think like I'm pretty sure that we capped the max weight as 100 milliseconds even with the compounding, so I don't think anything's ever waits more than 100 milliseconds.
Well, that's good, at least.
Yeah,
but 100 milliseconds could still be a long time in the time scale of that graph that you're looking at. Where, you know, in a world where you could like sync out every TXT in like a half a second, you know, 100 milliseconds is still a long time to wait.
Yeah, and in context of delays being sequential, I was thinking that somehow maybe it would be great to have them work in parallel. For example, if you have one thread doing large in big writes and other doing a lot of small writes, now they all get serialized into the same line. At the end, bandwidth of the thread doing large write will be much higher because they are all waiting, all of them having same IOPS.
Yeah. I wonder if this idea of like reserving how much you're going to dirty would kind of help with that as well, because then it's like the one who's doing the big write has to reserve that amount. It's not just like equal to all the other threads.
No, it could slightly reduce amount of dirty data in a counter, so it slightly reduce delay, but still, since it's all like they're all going sequential, you still get it's exactly same number of IOPS through all the threads, and
yeah, there's no attempt at kind of fairness between different writers there.
From one side, it all works in context of bytes, while fairness happens in context of IOPS. It's a bit weird. So I haven't got good ideas how to, like, from what then base the delays, because if we put them all from current time, not from the last one, then it will be slightly on the other side. More threads will be able to push more, but maybe it's actually okay. They will just put more into dirty data and then get all throttled at the end as a result. But maybe we should just deserialize them and rely on different.
Yeah, then I mean, the obvious way of deserializing them runs into the problem of like, if you have more threads, then you're like letting more IO go through, right? If every thread gets the same delay from the starting point, then like having more threads means you get to do more work at that amount of dirtiness.
No, it may be expected. I don't know.
Yeah, maybe. I mean, it means that you would move up the amount of dirtiness and move up the delay more. So maybe. I mean, that is how I coded it up originally, and then, you know.
So when we're deciding on the delay, do we know how much they're adding at that moment? I think so.
I mean, we don't take that into account.
But maybe
I'm suggesting that maybe we could, as part of this, and then have that be like this reserve, go into this reserve.
Because I think what we're trying to do is avoid just because you have a lot of threads ending up in the, the last kind of 10% of that chart where the delay goes up really sharply. You should be hopefully slowing down sooner than that. And coming to kind of equilibrium with how fast the disk is actually able to flush out.
Yeah, exactly. So yeah, I would definitely look at like, are we hitting this, proposed issue where like you have a lot of threads, as soon as the dirty data drops down and then they wake up, then they're all like, oh, like 1,000 threads all decided that the dirty data is low and they can all go through, and then like all 1,000 threads do their writes, and then the dirty data jumps from there to like into the delay range, when really we should have like, let enough of them to go through to get to the delay range, and then the next 900 of them should have been delayed a little bit. The graph, so can you talk a little bit more about, I mean, that might be like the right solution, but maybe like smoothing more would add a little bit of niceness as well. Could you talk a little bit more about what the PR is proposing? Like, I see this graph with the yellow line.
Right. So the blue line is what the delay, the right throttle does now. Although I think it's that's with it tuned.
With the minimum turned down, it looks like.
Yeah, with the minimum turned down. But the idea is that there's no delay at all, and then you hit that threshold where the delay kicks in, and that then we have that exponential curve or whatever there that increases the delay as the dirty data value gets higher. So once you've gone up that line, what this patch does is that after you drop below that threshold, instead of going back to 0 delay, it does the yellow line of keeping an amount of delay on until the write workload has kept below the point where it would insert a delay for whatever the tunable value of seconds is.
I see. So it's basically like if you've gone to whatever it is, 90% dirty, then you're going to apply the yellow line, meaning like you at these lower amounts of dirty data,
we're still going to apply some amount of delay to make sure that when a bunch more threads show up, that we don't run back up to 90% again, that we slow them all down
Yeah.
and hopefully more gradually
I
slot
feel
in.
like
But
I feel like this is kind of a hack around the real problem of like, why did like, if you have this high workload, why did the amount of dirty data ever go to zero, like ever go down that low? It should have been able to keep it high. But the reason we didn't keep it high is because we applied too much of this delay, you know, when you slammed into the limit. So, you know, this is like a way of saying, okay, well, like when you get out of that, like we don't want to oscillate, but really like if we applied like the idea properly, then you wouldn't be having this oscillation. It's really kind of a bug that you're slamming into the top, and then it's a bug that you're dropping down to zero after that, right?
And then waiting when you're close to zero sounds weird. Like if you're close to zero, you cannot properly aggregate, you cannot potentially do some other optimization. Going too low shouldn't be good. It's not right.
Yeah, like there's if there wasn't this issue with like a gajillion threads, then you know when you get down to zero, and if we said okay, fine, like you can go jump up to 30% dirty instantaneously, that's fine, and then like and then now you start having a delay, right? Like there shouldn't be a need to like delay from 0 to 30 and then start to you know, you should be able to get to 30, start delaying, then you have more or less the same behavior. I suspect the problem is like you're at 0 and then a million threads come in and they're like, great, we can all go. Whoop, now we're at 80% dirty. You know, you like instantaneously jumped from 0 to 80% dirty. And I think that something like this, like reserve, would prevent us from doing that jump.
Yeah.
Out of curiosity, do you know how many threads and how many CPUs?
Like 8 CPUs, and I think the threads is like 16 or so. It's not thousands.
Oh, interesting. So it's not that many. So why?
But I think maybe what you're saying is just all of them show up at once when it's 0. And
yeah, but I mean 16 threads, like how high can 16 threads move the amount of dirty data? Even if they're doing, I think the maximum size that we should be processing is 16 meg. Although probably 1 meg with zvols.
Well, the zvol, I think the vol block size is 32K.
Yeah,
but obviously the writes might be bigger.
It'll still do that as one transaction.
Yeah.
Up to some limit, which I thought was 1 meg. So you would think that like your 16 threads come in, they each do a 1 meg write. That's 16 megs. That's kind of how much you could jump. And then, you know, when the thread has to complete that and then come back and check again, it's going to be at, you know, 16 megs, which is like that's only a couple percent, right?
Yeah, exactly.
So maybe there's something else going wrong here. I was thinking like thousands of threads, because like I've tested this before with like NFS, you know, where on a Lumos you would have like 1,000 NFSD threads by default. On Linux it's much lower, although we've turned it up in our product to 1,000. So maybe there's something else going wrong here with the
maybe you could collect, put to the same graph just for better understanding different states of transaction group processing, sync processing, when it started, when it finished, when it started cache flushing maybe, and also add there average delay with some sampling or like something like that to see whether it's delay a problem or it's a problem of really ZFS going to some slow stages and then it has to accumulate more data that actually causes throttling.
On their system, you said it only has 16 gigs of RAM or something.
Yeah. So
what is the dirty data? I wonder, like, is the dirty data limit there just a lot lower? Because it's 4 gigs, but that's on large machines.
Right. I think there we were setting it to about 1.2 gigs.
Okay, so it's not tiny.
No.
And you've lowered the where the throttle starts.
the
even
throttle
further.
where it starts to try to get more
Yeah.
evenness.
So I
I
think
think
there might be
Alexander's
something
idea
else
of
going
looking
on
at
here.
that, there's the K-stat that gives you like the last 100 transaction flushes and how much time they spent in each state.
Mhm.
That and maybe trying to also profile the delays might give it, or sample the delays might shed more light.
Yeah, because I
No,
think
I meant more like try to correlate delays with exactly what ZFS is doing at this point, whether it's writing data, whether it's starting flashes or for the devs updates of last stages of sync, updates of labels, Uber blocks, whatever, and just to see on that graph where exactly it starts throttling. Maybe it's valid pulsation. Maybe the pool just have very long sync time for caches, no cache flash time or something.
yeah,
Maybe
I was thinking that it seems like the problem probably starts when you slam into the upper into like 100% dirty data and start doing this 100 millisecond delay. So, maybe one way to start looking at it would be, how did that happen?
Right.
Like, if you only have 16 threads, I would think that like, the amount of dirty data is like going up and up and up. And then like you get to like 1 millisecond delay, and like, isn't that like, shouldn't 1 millisecond delay be plenty enough to kind of bring the incoming amount of dirty data very low? Because you only have 16 threads, and you have 1 millisecond delay. We're only accepting one operation every millisecond.
Mhm.
But maybe there's something wrong with that.
Possibly. Yeah, all right, we'll dig into that one some more.
Yeah, so I mean, I think that this the PR like it would be nice if we could find a solution that isn't as like tunable, dynamic behavior dependent, and maybe we can find like a real bug with the existing stuff, rather just because like piling on more and more dynamic behaviors makes the system harder and harder to understand. So it's like we should definitely do that if we have to, but if we can avoid it, then that would be better.
Right.
just a last comment. I just looking now on the graph on its right side, and there's pretty small amount of dirty data that grow delay from 10 millisecond to 100 millisecond. It's really only like 5%. Just looking on the graph, I don't see numbers. They're pretty tiny there. And maybe that, or actually 5%, is that what 16 threads can actually drop in the last moment.
Maybe
Before they.
I think the idea was like you would almost never get above that.
No, like with single thread, I agree with you that single thread just can, because it can't write gigabyte in one request, because requests are pretty small, it should get slow it down much earlier before it reaches that point.
And then because the delays, if you have multiple threads, because the delays kind of compound, it shouldn't matter that you have a bunch of threads. Like it's the delay is basically like we only take one operation every 10 milliseconds, regardless of how many threads you have. Like that should make you really, really slow. But maybe there's some way to circumvent that if you have a lot of threads and it's not like the check isn't working right or whatever.
Well, we're definitely seeing the part where the writes get really, really slow to practically zero going through, and then it recovers and goes back to going faster than the disk could go, and then quickly ramps up and runs into having to slam on the brakes again.
Yeah, but I think that we should, the first problem is like, why is it ramping up so quickly and slamming on the brakes? Like, I would try to figure out if that is kind of behaving as intended, and it's just like the workload and the RAM and the memory size are not meshing well, or is it like somehow the ramp has been circumvented by, like maybe it's enough that only 16 threads come in and they check, and then they all see, oh, like we're at 0.1 millisecond delay, and then they're able to like jump it up enough that it hurts the performance a lot. All right, let's take a look at the next one that you mentioned. Spot A size inflation. Yes. I think that we talked about this, or I might have talked to you about this a while ago. Can you maybe give a summary of what things?
Part of what we saw there was if there was a quota or something on a data set that we'd end up having to stop and wait for the currently pending stuff to flush out before we could write more data to it. And it would get really, really slow because it was every amount of data you're trying to write, it was just blindly multiplying it by 24. So, you know, if you had, you know, 500 megs of free space or a gig of free space, and you tried to write 100 megabytes to it, it would say, actually, that will be 2.4 gigabytes. So we don't have enough room for that. So we're going to stop you after writing, you know, 20 something megabytes and make you wait for transaction flush before you can write more. And so that change goes and looks at each VDEV that you have and finds the worst inflation that that VDEV could cause and uses that value instead of 24.
Okay, and I see that there's still the tunable still exists and you change it to 12. When does that come in?
So that was the first change, was just that because we don't have ditto blocks anymore, we didn't need an extra multiply by 2 that was in the formula. So the default value could go down from 24 to 12. But yeah, I wasn't sure there. So we basically don't use the tunable anymore. So we should probably garbage collect it if it's, if we like what this is doing instead.
Get rid of it.
Yeah.
Okay, so that sounds like a good cleanup to do. So we can get rid of that, and then so you're calculating it dynamically for each VDEV based on like, oh, is it RAID Z, you know, that kind of stuff.
So each VDEV advertises its worst case, and then the pool takes the worst of all the VDEVs and uses that for everything.
And then it looks like it also takes into account the copies property.
Yeah, if it has a pointer to the data set and can check the copies property, it uses that, and if it can't get it, then it assumes the worst case of copies equal 3.
Yeah, cool. Yeah.
So this should also, you know, by accident help people that are running into, we have a quota on our NFS home directories or whatever, and when they're getting close to full, they slow down to like single-digit megabytes per second of writes.
Yeah, so you'll be able to get much closer to full before it starts slowing down.
Right, because we're not assuming you're actually going to, that every write's going to take 24 times that much disk space.
Okay. Cool. Yeah. Why don't you garbage collect that tunable, assuming that it really is no longer used, and then why don't you ping me and I'll take a look at it. This seems pretty straightforward and a nice win for those use cases. I mean, the performance improvement is going to be huge when you're in that circumstance.
Yeah, for sure.
And then the last one that you mentioned was the namespace delegation support, which I do not know much about.
It's basically the same way that you can delegate a data set to a zone or a jail on Lumos and FreeBSD. You can do that to a namespace, a user namespace on Linux. So that root in that user namespace can, you know, do ZFS commands on that subset of data sets. And it takes care of the UID mapping stuff that Linux supports, where each namespace has its own range of UIDs that map to the typical range.
Cool. And this hooks into the like zone, like is zoned permission check stuff. That's
it basically does actually hooks up is global zone so that it can tell if you're in the parent namespace and it's normal, or if you're in some other namespace, and then you can only see the data sets that you'd normally be able to see. And yeah, it just hooks up to all the existing stuff that Illumos and BSD use, so that it's following all the same rules.
That's cool.
Mm-hmm.
So we need to figure out who can code review this.
So I made a couple passes at it. I think it's looking pretty good. We had a couple open questions that I don't know that we came up with any good solutions for really, but they're probably not big deals and things we can live with. So it'd be great to get additional eyes on it. But I think it looks pretty good. I think that one of the bigger questions was just that we're happy with like the CLI interface and how it shaped up and that kind of thing. You know, we, like Adams or Alan said, we're tying into exactly the same machinery. So we're doing things like overloading the semi-octal numbers and stuff like that, and which seems fine. We just got to decide that we're happy with that kind of thing.
I assume that there are some kind of changes to the CLI, not just the API, but the CLI.
Yeah, it adds a new command, like ZFS
user NS
to namespace it.
Right.
Yeah.
As opposed to ZFS zone or ZFS jail.
Okay.
Did we end up changing it to actually use zone?
We might have changed it back to zone.
Yeah,
I know we tinkered with it a little bit because there were like subcommands and subcommands and subcommands, or
yeah.
It got a little deep. But I forget what we settled on.
But yeah, I think we ended up going with zone and unzone or something like that.
Okay. Maybe for review purposes, if you'd like to have folks review that, the command line interface, user interface, which seems like a good idea. Could you write that up in the first comment? Like I see in the first comment, it just says like, oh, ZFS user NS attach, like some random number and then a data set name.
Mm-hmm.
So it would be nice if you could put like, maybe the rendered man page or like a description of like, here's the new subcommands, here's the arguments, here's how you would use it. And then probably more people are going to be able to understand that and give meaningful feedback on it than necessarily the details of the code.
Right. Yeah, I'll put a comment in there then about what the user interface is like and make sure that everybody thinks that makes sense.
Cool. I think that at one point we wanted to make sure that any user interface changes were reviewed by the broader community, including like, folks who might not be on this call or even using the OpenZFS repo, like most folks. Could you maybe paste that right up into an email to developer at OpenZFS as well?
Sure.
Thanks. Especially if we're if we're like, it's kind of related to ZFS zone or whatever, that most folks might have thoughts on, their experience with that. I don't know.
Right.
Maybe they're like, oh, that command is actually really hard to use. We should have done this other way. Maybe
right.
You can fix that or something. I don't know.
I think we're pretty happy with the jail command on the FreeBSD side, but yeah, I'll send that out to the list and get anybody else's feedback too.
Cool, thanks. Okay, any other topics for today?
I just mentioned that this is probably not an exclusive list of things that need reviews. If people have time or interest, there are more than enough other issues in the pull request open that could use some feedback and eyes on them. It's more and more every day. So
yeah, and thanks a lot, Brian. I know you've been doing a lot of the gatekeeping stuff. The Delphix team has been pretty distracted with we're working on getting the object store, ZFS on object store product out the door. So,
yeah.
But hopefully in the next few weeks, that will happen, and then we should have some more bandwidth from the other maintainers and hopefully code reviewers as well.
Yeah.
So
Well,
feel free to, maybe not this week, but like starting next week, feel free to more aggressively bug people and remind them of the responsibilities that they've been putting off, myself included, for sure.
well, and anybody can do code reviews too, right? If they want to comment things and look at stuff, right? I know Alexander's had some peers outstanding for a while now that, he was looking for reviews months ago. And there's lots of them out there that are like that for cool features and cool functionality. They just need more eyes on them, right?
Yeah, I was just gonna say I have 12, 7, 8, 9 improve log space map load time, which hangs like for 3 months. We are already including it in our releases, and obviously would like to have it upstreamed, or at very least some eyes on it, just in case I missed anything. Like, it works for us, but just eyes are always good to have.
Yeah, let me find the link, and then I'm gonna at least ping Seraphim, because I think that he might have time to look at this soon. Have him take a first pass, and then I'll take a look at it at some point as well.
I'd appreciate. Thanks.
Do you want to? We do have just a couple minutes here. Alexander, do you want to highlight like what the change is?
There are like a general problem is that there is no upper limit for number of dirty space maps. So if we have huge pool, like, there is upper limit, but it scales with number of VDEVs. If number of VDEVs goes to like many hundreds or thousand, then a number of dirty space map can reach, I don't remember, dozens of thousands. And it's practically require head seek for each of them to read them on pull import, and then CPU time to process them. And question whether it makes any sense to have so many of them before flushing from spacemap log into main spacemap storage. And in my limit, in my patch, I'm doing by addressing from two sides. From one side, I'm limiting maximum lifetime of log to 100 transactions or transaction groups, so that they never accumulated too much. From other side, I've implemented parallel read of the log, so that at least I can accumulate or amortize all the read latencies, so it's practically get CPU bound even on hard disk pools. For SSD, it's not so dramatic, but for hard disk, read latency is substantial, and there I see like 10 times improvements and more.
Cool.
Partially because of latency reduction, partially because of maximum history length reduction. So both sides help, and to me it doesn't look controversial or questionable. It's more like in case I missed anything.
Yeah, I think the idea of tying it to the number of VDEVs was that as you have more VDEVs, you can do more IO in parallel. So like in theory, all else being equal, you add more VDEVs, you have more logs, but then like assuming you're reading them all in parallel, you could you could load them in the same amount of time because your pool can do more IOPS.
No, from parallel thing, that's should be helped now with parallel reading, but problem now it's getting CPU bound.
Okay.
Because all the processing has to be done in single thread, because it's a log, it's sequential.
Yeah.
It can't be processed in parallel, and it's really CPU bound. I really can sit and watch for many seconds single CPU thread just burning, and that's why I'd like to have also a limit on maximum time distance.
Okay, yeah, that makes sense. I was just trying to understand if you're hitting that. Yeah, that totally makes sense to me. I'll take a look and see if Seraphim can take a look at that too.
Thank you, boss. I'll wait.
Thanks.
Maybe
Thanks for your
debating.
patience. All right. So I saw somebody posted something in chat. This will be the last one that we have.
Yeah, I threw two small review requests into the agenda notes. First one is on supporting incremental receive of clone streams. I think we talked about that recently, and the other one, hold on, is this one. It's getting fairly old now. It's a pretty edge case erase condition between ZFS zget and ZFS znode DMU fini. I think I illustrated it pretty well. I have no reproducer for it, but I think we should fix it nonetheless, because use after free of a znode can be pretty devastating. Like in memory znode can be pretty devastating. So yeah. I mean, I see who is assigned there. So
yeah, you can.
Okay.
You can ping them for sure. All right. This is probably a good place to end the meeting. Thanks for all the contributors' work on that. I know the leaders and other project contributors have been a little slow on getting these things reviewed and merged. Hopefully we can pick it up a little bit in the next few months. But thanks everyone. See ya.
Thank you.
Oh, the next meeting, it'll be the later time. It'll be, I think, also in March, because we do it 4 weeks. So 1, 2, it'll be the 29th, 1 p.m. Pacific time. Bye.
Thank you.
See you.
Thank